The canvas black with whispers gold, stories untold, secrets unfold, diamonds scatter where the shadows sleep, infinite skies, a promise to keep. Beyond the lights where the stars collide, a universe vast where wonders hide. Above our heads, a cosmic dance, an endless dream, a fleeting galaxies were like painted streams, brushing the edges of our dreams. Planets hum their silent tune, chasing the sun, kissing the moon. We look but don't see, we forget to believe. Beyond the lights where the stars collide, a universe vast where wonders hide. Above our heads, a cosmic dance, an endless dream, a fleeting shade. Nebulas bloom in colors untamed, every spark a fire unclaimed, hidden glory just out of sight, a quiet roar in the endless night. Beyond the lights where the stars collide, a universe vast where wonders hide. Above our heads, a cosmic dance, an endless dream, a fleeting
You know, every time I hear that song, I'm reminded of just how beautiful the universe is. Hello everybody, welcome to Sky Tour live stream. Is I Mark D'Antonio, at least I think that's who I am. Everybody in my house is out at a Super Bowl party, and I stayed here so I could do this. Shh, don't tell anyone. I'm probably gonna get in trouble now. So how are you guys? Welcome, it's good to see you all. Okay, we Star Panda. I don't know why your name is that, but that's cool. How you doing? Michael Hendricks with us. I see Daisy and Zoe have found us. That's good. C&D boy, that's Bob. How you doing, man? And then Dagger Spells, good to see you as well. Keith Evans, nice to see you. Tim F, woohoo, nice to see you. Genghis. Okay, you can always tell the non-football people. Rockstar, maybe you guys are football and you got this on at the same time, which is fine, right? Doesn't matter. I think that's fine. So tonight we're going to look at a few really cool things. This guy right here, well, this is the double cluster in Perseus. I'll show you where that is. And if you want to find that, you can see this with your eye, which is really interesting. if you find the W of Cassiopeia right down here, see that? Okay, here, let me come over and show you. So here's the W of Cassiopeia, right there. 1, 2, 3, 4, 5. You go to that N star, kind of on a long angle, and you go just behind it, okay, or follow it toward the other bright star in Perseus, which is this guy right here. This is called Merfac right there. Okay, that's Merfac. If you go in between that N star down here in Cassiopeia, right, that guy right there, you go from there, you go toward Merfac. It's in between, about just under half the way, and it's right there. Okay, and you could see it with your eye, you could see it with binoculars, you know, which is really cool. So it's actually a very nice little cluster, and it's one of two. There's actually two clusters here. If we zoom in on it a little, you can actually see that. Watch. Okay, so if we bring that front and center, see, we're on this cluster right now, and we have this cluster. Now, this cluster is a little bit closer to us, and the other cluster is a little bit further away. They're kind of like this in space, but because we're seeing it projected along our line of sight, it looks like it's, you know, right next to each other, but they're not. They're actually very distant, not very distant, but a couple hundred light years away from each other, which is kind of neat, you know. And Shelly's with us, Shelly Gormley. Shelly said she might show up. Pop Culture Minefield, that's Gary. What's going on, man? What's up, brother? All right, he's here. And Fantasy's with us. Fantasy X Channel, hey, man. And he says, just got back from the big Dark Sky Festival in Death Valley. Wow. I want to hear more about it. How was it? How was it? You know? And we have, let's see, Fantasy says, I was just looking at the double cluster last night in my binoculars, very visible with the naked eye, and you gotta be somewhere dark. Yeah, with binoculars, if you know where to look, you can see it anyway. But you're right, it's best when it's in a dark sky. And you want to really have a trick and a real treat, if you can do this, okay? If you can get binoculars that are gyroscopically stabilized, I know, sounds like it's very expensive, but they're not, okay? You can find some maybe for $175, $275. Gyro-stabilized binoculars change the view entirely. It makes it really look 3D because it's not bouncing around. Like if you look at my camera, it's not doing this all the time. It's actually rock solid stable, even though you're bouncing around a little bit. So those binoculars are worth the extra $75 to $100 you pay for them. And if you really want to get a treat, look at the moon with them. When you look at the moon with your binoculars now, you kind of have to slow down and breathe carefully so you can focus for a split second on something that's not moving because you can't hold still so much and they're magnified. But with gyroscopically stabilized binoculars, when you look at the moon, it looks like a round sphere. It really looks beautiful. So those are something to look for, you know. I think that's pretty cool, you know. And then Gary Kissel comes in with another ID. He came in with Pop Culture Minefield, and then he came in now with Gary Kissel Pop Culture Minefield, PCM. You know, and he says, Mark, do you have 2 streams running? I was waiting for 10 minutes while you were live. No, I only have one. I don't think there's another Mark D'Antonio doing this. I did have a problem with someone trying to... and someone actually tried to steal our SkyTour livestream website, YouTube channel. So it used to just be SkyTour livestream, and then he made a SkyTour livestream channel in an attempt to take it. And then I changed the name to SkyTour livestream with Mark D'Antonio. It wasn't a ego thing; it was just a protection thing. And he very soon after got rid of SkyTour livestream because it wasn't going to work. In any case, that's why my name is in everything that I do, because of that. Just so you know. Let's see. Fantasy says JPL and SETI were there along with NASA. Oh, cool. They must have been doing some kind of experiments out there, I imagine. Tell me what was happening out there. All right, let's do this. Let's broaden our curves here a little bit. All right, and let's color correct. There we go. And now let's pull the black level back before the curve so that we actually get what we want. There we go. Look at those beautiful red giants in there. Look at that. In this cluster here, what's happening is it's evolving, okay? And it started as a young cluster of hot stars, but they go through their hydrogen pretty quickly. And so when they do, they evolve. And one of the evolutionary stages is to turn into a red giant. And that's what we see here. And this is the cluster to the right in the planetarium show thing I was showing you. Okay, and these red giants are the evolved members of this cluster so far, and there's going to be more to come. I have a giant curved screen here, so when I look this way, I'm really looking at the same thing you see over here. So I know it looks weird, but I'm actually looking exactly where you're looking. All right, so the curved screen is really good. It's a nice panorama screen, which I took from my son's room. So he said, "Oh, you can have it, Dad." I was like, "Yeah, thank you." So, you know, our children sometimes do good things for us. Anyway, so this is double cluster, and I've got it labeled there, and I'm going to save this image here. This is 31 frames. I started doing this before you guys came in. I always want to have one really cool thing for you. Also, if you saw my community post I put out there for Skyter, you saw that now the telescope in the Sonoran Desert, the wide field system, has the same exact mount as this one here and operates the same way with the same software. So now these two telescopes are unified. They do the same thing. Now you might say, well, where is it tonight? Well, for tonight, we're actually we have to do another maintenance run out there because it ran great for about a week, and then all of a sudden it stopped showing up, and we weren't sure why. So we'll see what happens, you know. Yes, Fantasy, you read my mind. We are going to do M81 and M82 as well, because it's sort of in the vicinity. I do have to check, for instance. Let me go do that. While we're waiting, we're still collecting images here. Let's back out a little bit. All right. We have clusters here as well, and I have a few others that I want to go to. But let's actually try to find M81. Okay, yeah. See, M81 is kind of near the horizon right now because it's literally down below Polaris. Okay, so it's actually kind of a little bit below. I mean, Polaris is here. Sorry, and so it's kind of low, but we can still see it, and we can try to image it. It's going to be not as good. It's only about 30 degrees above the horizon, but as the night goes on, it's gonna get lower or higher rather. So we'll be able to actually be able to image it better later on, but we can try it. And then there's this. Who's this person? Marianne Robb? Who's that? Everybody knows. Marianne Robb is the heartbeat of STLS. She's our CFO, and she's for our nonprofit, and she's also one of the people that does a lot of the maintenance when I can't be there, obviously. So, funny story, you probably saw it when we were out there doing maintenance, her and I on the telescope, just a few weeks ago, end of January, I believe. We ended up, I had remembered that there was a tarantula in the building one of the times before, and I said, "Hey, I wonder if there'll be a tarantula under the computer table again." And I was just kidding. And I pulled the table away, and there he was. You know, it was back, and it might have been the same one that Tara, the third person in our nonprofit, might have seen, and her husband took it out. They're very docile. Now I was holding it, and the only reason I was holding it is because it was dead. Okay, I'm not yet brave enough to hold a live tarantula, and Marianne held it, to her credit, you know, so I thought that was pretty cool, you know, because she's, you know, I mean, spiders like that with 3/4 inch size fangs, you always imagine the worst, you know, bit me in the face, you know, or whatever, but these are very docile, and they're extra docile when they're dead. So it was kind of cool to see it is desiccated, meaning it was actually kind of mummified. But I took it and I put it out on a rock where it could sit and enjoy the starlit skies at night. You know. Anyway, I see that Donald Kunzer has joined us. Good to see you, Donald. All right, very, very nice, very nice. So you guys are the diehards, you know, to check out this stuff before before the Super Bowl is over. In any case, I am going to do one more save here of this object, and then we're going to move on. Yeah, let's see here. We're going to save exactly seen. Marianne says, I only held it on a towel. Any spider is icky in my book. Well, okay. You know what? For all the bravado that I had, okay, I was holding it in my hand and I was just a little unnerved. I mean, I went into a pet store here in Connecticut where I am. Okay, not out there in Arizona where the telescopes are. And they had tarantulas you could buy as pets. And I guess maybe part of it is that slow walk they have. You know, they like, yeah, I'm coming towards you slowly. And then they go and they raise up those first two legs in a threat display. And it's like, okay, I'm out of here. No, you know. Gary puts up a spider icon. Thanks. Bill New York Skywatcher, who is now also going to be the producer for the new radio show I'm starting on Unexplained Network, Sundays 8 to 10 p.m. Eastern Time. He's also very afraid of spiders. I'm not deathly afraid. Neither is Marianne, but he is. And so you know what we do, right? Send them pictures of giant spiders, things like that. Anyway, let's see. I got we have ZIDRYG. Hi, how are you? Zidrig. I'll call you Zidrig unless you tell me, unless I missed something. But yeah, how you doing, man? Welcome. If you haven't joined us, it's free, man. Just subscribe. We're a lot of fun. We have a lot of fun. So what I'm gonna do now is we've got these guys, 54 of these images. We're done. That's the stack. I'm gonna save it exactly as seen. It's going to our server, and within seconds you'll be able to go to the server, and when you get to the server, skytourlive.org, and scroll down and say, take me to cool pictures, and you can then get this picture and download it all for you. Okay, so now what I'm going to do is I'm going to have a low light mode right here. So this is the live view, little 1 second images. Mark, there are 2 streams running. One is still on standby. I'm not running 2 streams, but I guess it must be true. All right, let me go look. I mean, this one is running. I don't know what else is running. Let me see. I will check it out. I see only one live one. I see an upcoming one. Oh, I know what happened. Okay. Yes, it is upcoming, yeah. And the reason is because I changed the title after it got going. So I will get rid of that later. It doesn't really belong here. Okay. Yeah, that one's not gonna. What the heck? Oh, sorry. That one's not gonna go anywhere. Okay. Thank you, guys, for telling me about that. I'll remember not to change the title after it gets going. All right, let's go here. And as promised, we're going to go and look and see if we can get to M81 here. So we're on our way. There go the stars. Yeah. And we're getting a complaint from our guiding system that says, no, we're not guiding on anything. Yeah, there you go. All right. So you can see the telescope swinging around right here. This is the business end of it right here. That's where all the good stuff happens. Okay. Now let's see if it knows if it's here. It may not be because it's all right. Okay, don't have enough stars. Let me actually take a 5-second exposure of this field. We'll do that. All right, and we'll get. Let's see, that looks fuzzy. I'm not sure if that's it. Anyway, let's see what we get. Okay, so it didn't find it, but it was able to find itself. So what I can do is tell it to, well, find where you are and then move to it, and then it'll be dead center in the image. Works very well. So I'm going to do that way. And there it is, right there. Boom. Okay. Now, if you guys haven't seen this before in our telescopes, you're in for a real treat. Okay, first of all, this telescope is a telescope that actually has more focal length, meaning that we see things bigger in the view, and more pixels for the camera are allocated to it. So I know it looks like a fuzzy blob right there. What you may not realize is there's a whole galaxy right here, and you just can't see it yet. But you will in just a moment. All right, so here's what we're going to do. The first thing we're going to do is get a guide star in here, and I'm going to do this first. Okay, and it's got a pretty faint view for guide stars, but we're going to do this. There we go. That's a perfect guide star. All right, and now the telescope's going to be micro steered to keep that star inside that crosshair. So as it stabilizes, you'll see that thing get closer and closer, and it measures what's called the centroid, or the brightest point of that object, and it's going to pull it toward the center, and it's going to lock onto it. So we have to let it stabilize for just a bit, as it's doing now. All right, and then what we'll do is we're going to do a, I'll say, 45-second exposure. This is what you might see in like a normal small telescope, okay? You know, but in a good scope like ours, yeah, it's good. What can I say? All right, if we're gonna do this and we're gonna teach people astronomy, we've got to have reasonably good equipment. Blazer MT, what's happening? All right, now let me go here and see what that's doing. Yeah, okay. Once in a while, it loses its guiding capability for some reason. All right, but we're almost there. We're 10 seconds from an image. All right. Yeah. And cosmic ray is with us. All right, now that doesn't look like much, but that's because I had this over processing on it. If I turn that off, all right, now you start to see something. All right, now I have the gain at 100. I'm going to change it to 200, and I'm going to clear this and do it again. So the next image that comes in is going to be a mix of 100 and 200 gain. Over here, the gain and the exposure. The gain is here. That's the sensitivity of the sensor, and the exposure right over there, right here. Exposure and gain are the two main values that you play with. You want the highest gain possible for the exposure that gives you the least amount of noise. The gain is the one that gives you noise. All right, so here it comes. Look at that. Look at that. That's beautiful. All right, so what we do, you can see it's got this little reddish haze. I just color corrected that out. We are looking at a very low object in the sky. And as I said, because we're looking here, right, if you look down at our horizon here, we'll back out a little bit, right? You see we're looking to northeast, okay? As night goes on, this is going to get a little higher in the sky. How high? Well, if we look at our rotation, you can see that it's going to end up, okay, up here before you know it. All right, because the Earth's rotating toward the east, and so we're going to whip all these things around to the west, because the west is that way in terms of this So that is pretty cool. So it's almost level with the pole now. And you can already see the blues showing up. These blues are the young hot stars. I can make some adjustments to make that even more clear. All right, this is Measure 81, Bode's Galaxy. All right, and we're going to take this as the name and set that as our target. Here we go. All right, so now when I save it, the image is saved in the M81 Bode's Galaxy location, and then we save the PNG file, the image file that you can just click on and see the picture just like you see it here. The FITS file is a astronomical file format, so that if you want to do your own image processing, then you can. Oh yeah, so as this comes in, you'll see the details in here getting sharper and more crisp and clear. And so that's what's neat about this. We have an awful lot of dynamic range with this camera, which means we can see very, very faint stuff, and we can see very, very detailed stuff. And we can also knock down the brightness in the core without losing all that faint detail. Look at this spiral arm dark lane here. See that? That just showed up, you know, as we got the fourth exposure here. Right? We got the fourth exposure here, and that little dark lane just showed up. Okay, we're starting to see modeling in here. Okay, it's just looking great. And this galaxy right here, right, is actually, if you look at how far away it is, okay, this particular galaxy is, oh gosh, was it 11.8 million light years, right? And if we look at Measure 81, which is right near it, which is this guy, okay, otherwise known as the Cigar Galaxy, this one is 12 million light years away. So what you're seeing is you're seeing this light as it was 11 million years ago. So if you look back on the Earth and look back at our time frame and say, hey, what was going on the Earth back then? And then you look at this image right this second. Well, whatever was happening 11 million years ago, the light that left at that instant is now reaching your eyes today. I think that's pretty cool. You know? And Gary Kissel said, sent you a PCM about the other stream with a link. Thanks. I did find it, Gary, and I know that it's because I changed the title midstream. Probably shouldn't have done that. But that's kind of interesting. I'm wondering if I can figure out a way to use that to my advantage. Wow. By the way, just so you all know, you guys, I think, know that I work on History Channel's Proof is Out There TV show as their chief photo and video analyst, along with MUFON. But we did just get signed on to a 6th season, so I've already received a bunch of stories I have to look at, and let me tell you, this season's looking pretty cool. It's looking pretty cool. So I'm going to have my pre-filming interview where we're going to discuss these in March, and then they're probably going to come up early or late March to do the filming, which will be nice. Then in April I'll be in Arkansas at the Ozark Conference. That's April 9th through the 12th. And then end of May, I'm at Contact in the Desert again. I'll be doing 3 lectures out there again, 3 different ones. And then I will be, after that, not sure about Pine Bush, but I do know that in the middle of June, I'm going to be in Illinois, down in Bloomington, actually. Is it Bloomington, Illinois, or Indiana? I think it's Illinois. Yeah. And I'm going to be, there's going to be 2 speakers at this conference, and they asked me to be one of them, which is nice. And then turns out, let's see, that's June. I don't know about Pine Bush. I haven't heard anything about Pine Bush, New York. I've been speaking there every time it's come up, but haven't heard anything yet. So Maybe they've got tired of me. And then let's see. Julie Powers, come to Maine. I've been to Maine. I love Maine. My relatives are the entire town of Port Clyde, Maine. I know, it doesn't say much, but it's true. Yeah, I love it. Old fishing villages. Oh. I spoke in Halifax at the Shag Harbor UFO event this time. And I gotta say, Halifax and the Shag Harbor region of Nova Scotia, it's just an extension of what Maine looks like. It really does look like Maine. I saw the same lobster traps on the docks. I saw the same fishing boats that I've worked on and spent all the years getting seasick on in Maine. So it was all there, you know, so it's kind of cool. Really neat. Yeah. Let's see, so June is the Bloomington conference. July, I've been invited to Roswell, but I'll be speaking at the UFO Museum in Roswell this time. I've never spoken there before. It's the first time. I'm glad they finally invited me. I've always wanted to speak there. And then August, September, open. Everything's open after that as far as I remember. I'm probably misremembering. But no, it's pretty cool. Let's do this. Let me move that down. Do this. Come on. Go down here. Oh. We'll auto hide you. There we go. So we can see this bigger. Look at that. Huh? Isn't that better? Yeah, this is nice. Now this, you can see now this, this beautiful center dark lane is now showing detail. Look at that little, I guess you call it micro details in there. That's incredible. Not bad for looking at something that's 11 million light years away. Wow. Yeah. We have 11 frames stacked here. 11 45-second frames. What I'll do is I'm going to bring this up. I'm going to go to my histogram and I'm going to just pull this in a little. Brighten up the whole package. There we go. And let me color correct because that might actually help us see things a little better. Okay, it didn't make a lot of difference, but you can see the blue. Spiral arms in galaxies are the place where stars, of course, form. Okay, generally. The center is stars that have long formed and form the core of the galaxy. But then these spiral arms are more turbulent areas where there is pressure waves from supernovae. And when I say pressure, I mean light pressure. You know, L-I-G-H-T, that is from the light. Okay, photon pressure. Pushes outward and the material itself forms a shock wave moving out from a supernova. And those little shocks in a location where there's no gravitational forces whatsoever will make a huge difference and will cause things like stars to form. See this clump here? Look at this clumping here. This is a region of very, very hot stars that are formed here. And we see other regions like that. You can see a reddish area here, nebulae. This is, again, one of those places in the galaxy that's actually got a lot going on. And let me see if I can just eke out just a little bit more. There we go. Yeah, there we are. So now you can see even better. Now you see there's a clustered clumping of stars up here, star groups out here. Interesting we can see these though, right? Considering that we see them in the Triangulum galaxy, Messier 33, don't we? And in Messier 33, they're very clear. You can see swirls and spirals of nebulae. Okay, but that's only like 2.8 million light years away. This is 11 million light years away. Okay, so it's actually 5 times plus further away, and we can still see some of these details. Look at this one showing up now. This is beautiful. And we're up to 15 stacked images. You can see down here in the bottom. And make sure you're on 1080p so you can read all this little stuff if you want. You know, we are using the Benson telescope, which is the high focal length or very, very magnified field telescope. Yep. I'm going to bring this up and save this at 15. And then save again. I'm saving the science file, the FITS file it's called, and I'm saving the PNG file so that you'll be able to go download that file. Okay, this is the file right here. All right, this is being uploaded right now to our server. It'll be downloaded to our server. You know, it'll be there in about 30 seconds from now. And you could go to skytourlive.org and download this very file we just took. All right. You know, I like giving people stuff. When you guys come here, I want you to have stuff. You know? Yeah. And here's Lori at LDP. Nice to see you again. Thanks for coming back. This is a galaxy that's just over 11 million light years away, as Fantasy told you. It's called Messier 81, or Bode's Galaxy. It's a spiral, as you can see. Wouldn't you like to be in like the stars that are way out here on the edges of the galaxy? You stand a chance to be kind of left behind. That's cool. Yeah, look at that. That's neat. Yeah, there we are. Yeah, we're getting a little more detail here, and you can start to see more detail coming in here. Nice, very nice. Okay, let me just do this. Pull this down a little bit so you can see the rest of it. Yeah, there it is. That's a beautiful galaxy. Gorgeous galaxy. And it's all yours for the low price of 0. I always like to say, oh, and Ronald asks, is this live? Ronald, it's always live. It's always live. It's not, you know, it's not, I don't ever show this screen if it's not live, Ron. We're in a live situation here. Yep. So, by the way, I'm going to tell this, Ronald, sorry. We were out doing some maintenance on this telescope some weeks ago, and we we visited Ronald and gave him a birthday cake because it was his birthday. And then we took him to see the observatory. Because this observatory here, the instrument was, you know, we were grateful that Ronald actually purchased the instrument for us with a donation. It was very nice. And so let's show him some love out there, because he did a very nice thing for us. Yeah, that's our Ronald, ERRT Radio. Catherine Messick is with us. Nice to see you, Kathy. Kathy, if I don't miss my guess, you visited Kip Peak recently. I want to hear all about it. I think everybody would like to hear about it. Let us know what happened. Okay. All right, so we're up to 20 images stacked. We're going to save it. Save again as seen. Nice. Okay. All right. That's good. So what we're going to do now is we are going to return to our docked position here, and we're going to leave this galaxy behind and go to another one that's slightly further away but shares a physical locality of the other one. In other words, it's right near the other one, and that one is not M81, which is what this one is, but M82. And M82, you'll be in for a treat. This is a strange one, so check this out. Off we go. Yeah, there we are. There's M82 right there. And we'll stop our guiding. Yeah. Yep, Fantasy. By the way, the reason we're doing this is because Fantasy asked for M81 and M82. So I thought that was a good idea. So let's get a guide star here. Grab a guide star. Got a perfect one. We'll do that. So you want the peak to go up and down. You don't want to go flat on the top because that means it's overexposed. And if it's overexposed, the telescope moving within that flat top can change its focus along the top there. We don't want it to. So we want to make sure that we see the whole curve when we're in here. Okay, so we're guiding now and we are stabilizing. Good. So now we can do a 35-second photo of this, and we're going to be at 200 gain and 35 seconds, and 35 seconds is going to be a very good exposure for this. And then you're going to see something strange. This galaxy, when I was getting my degree in astronomy, we called this the exploding galaxy or the starburst galaxy. And I did some research photos of it when I was working on my astro degree. And one of the things that I noted was it had this outflow at its north and south pole, which was very interesting. Now, Kathy, who visited Kitt Peak, I'm so mad. No, I'm not. I thought it was great. Kitt Peak was amazing. I want to go back and spend more time there. To see those big observatories open and start viewing is astounding. Did you see our curator for our location here in Benson there? His name is Dean. Did you see a guy named Dean? He's director of, I think, Visitor Affairs or Visitor Center. And so he is the guy that is really something there. He's responsible for managing this mountain that we're on here. And so it's pretty cool. So here you see this galaxy. It doesn't look like a galaxy you're used to seeing, though, does it? I'll tell you why. This galaxy may have been more normal at one point. However, what happened was it's in the vicinity of Messier 81. And Messier 81 and Messier 82 here have interacted because they're loosely bound to each other. So as Messier 82 collided with Messier 81 in some fashion, maybe not directly, the gravitational tugging by Messier 81 distorted and changed what's going on in Messier 82, resulting in a tremendous burst of star formation. These red nebulae are massive galaxy-wide stellar nurseries. So this galaxy has got lots going on in it, and you can see the faint projections out of the top and bottom here. You know, oh, Kathy says Dean was there. Yeah, so you got to talk to him. That's fantastic. Yeah, Dean Salmon is a great guy. And now Earth Radio is screaming at me. No, I tell people if they want a question, they have to put it in caps. It's fine. Mark, where is that astronomy place that has the longest scope? I think they said in the world in Arizona, some kind of museum. I think there's the very large telescope, the biggest telescope is radio telescopes in China. The biggest visual telescope, well, it's kind of hard to say because the Vera Rubin telescope is a very large telescope, but that's down in Chile now. We do have the is it the gigapixel telescope out there too. I'll have to look that up, Ronald, because I actually not sure. There were several projects that I was looking at in that regard. So I thought it was like it has the biggest sensor, a gigapixel sensor, and I'll find that out for you because I also want to know. Absolutely, you know. All right, so Messier 82 here. Actually, I'm going to do this. First thing I'm going to do is identify. There it is. And then we're going to set the target name, save the image with annotations, and then we can get rid of it. We don't need the annotations here. And then we have 6 images taken right now, and I'll just save them to have a safety. Like that. Here we go. All right, and that's that. 1 second. Okay. I just heard somebody come in. I am, yep. Okay. All right. So, that said, I'm gonna find that. Like I said, sorry. Ronald says, I found it when I was looking for local observatories. It is, Mount Graham is probably where it is. Yeah. I mean, Stewart Observatories, I think Stewart is up on either Mount Graham or Mount Lemon. Oh, so he did find it. Okay, good. Thanks, Fantasy. Hey, Mayhem KB, what's happening? Large binocular telescopes on Mount Graham. I've seen that. On the way to Tucson, you can see it up on the mountain. That's the LBT. That's really cool. It's the BLT. It's the bacon, lettuce, and tomato telescope. Yeah, that's a really cool telescope. All right, watch this, guys. So I'm going to over process by hitting this over here, and you'll see those projections out of the top and bottom. So look at that. You got them up here and then down here. They go up and they go down. And let's see if I color correct that. Yeah, so you can see the red more clearly now. It's still a little low, so you're getting a hint of horizon haze a little bit. In astronomy, we typically don't look at anything below 40 or so degrees in altitude when we're doing serious work, because we can't depend on the atmospheric quality to get good imagery. Okay, so let's pop out of that. So look at that. So this galaxy, then we're seeing it kind of from the side, so we can't see any face-on view. We don't know whether it's a spiral that's just got lots of stellar nurseries in it, but we're looking at really displaced dark clouds here, dark lanes, and dark lanes would be more horizontal to the side. All right, so it's possible that we're seeing this at a slight angle like this, and so it's coming around and going this way like a shallow ellipse. It's possible, but we're looking at it now. You see that red projection there? It's really strong now, and it'll get stronger. It will get stronger. I can actually try to just over process slightly to show that, and then maybe darken it up a little. Darken you up. Yeah, see? So now you see those verticals a little better. They do show up better when you do like full-blown processing, which I always do on the imagery. Yes. Oh, wow. But yes, this is M82, and this is 13 images taken so far. I'll save those. I saw Julie Powers asked about the Pleiades earlier, and we might be able to do that as well, Julie. This telescope, though, can see like one of the stars of the Pleiades. It's a very high focal length, but the beauty of it is you can see the gorgeous dust cloud that the stars are embedded in. It's really something, wow. So I'll show you that, and so I'll do that now. I gotta see if anybody else has asked for anything else. I know that Yeah. Yeah, fantasy. I'm actually gonna look at it while it's high in the sky. I like to get pictures of these objects when they're high in the sky. Okay. And, later in the season, this will be way high in the sky, and we'll be able to view it better. And so this is a lousy shot of it, effectively, because you're seeing like reddish stuff around here. I can color correct to some degree, right? And some of it goes away, but because the curves are lined up. But the red stuff is due to, atmospheric hazes. Even in a dark sky site like this, you have atmospheric haze. I don't know if we have other astronomers working tonight up there. Let's go see. So watch this telescope right here. I'm going to move it over here. I'm going to look to the right. Let's see what we got. How about that? We appear. Hold on, let me see. Okay, he's open, but he's not. His telescope is still stowed. He hasn't brought it out yet. Normally, we can see our neighbor's telescope when it's up in the air, looking around, and we don't see it right now. Okay, all right. So 17. We're gonna go to 20 on this, and then we're gonna go to Julie's request for the Pleiades. I'm gonna show you a particular star in the Pleiades that has this beautiful nebula around it. Now, these are young stars. Now, the Pleiades, we call them the Seven Sisters, and you see 7 stars in the sky. Your eye can only see maybe 5, 6 in a dark sky site maybe, but there's 1,000 stars in the Pleiades overall. And what's neat about it is when you look at the Pleiades, all right, you see this star cluster, and you see all this blue dust, this blue reflection nebula around it, and that is the starlight actually bouncing off of tiny particles of dust, effectively, and showing you where the dust is. And it turns out that dust is actually something that might extend all the way to our solar system. We might have been viewing the universe through the very same clouds of dark dust that we didn't even know about. So that's one of the latest potential findings, and that'll be confirmed with other findings. Look at this before we close out. Look at that right there. Look at that curving around. I'm beginning to think that maybe we're looking at the galaxy more like this. Okay, and we're seeing the center here, all right, and it goes around like this, and this stuff is coming up and then going out the bottom, all right. But I'm also seeing this like the curve looks like it's curved around. I'm gonna have to do some research because I'm wondering whether we've thought about this all wrong in astronomy. That we may have thought about this particular cluster all wrong, or I'm sorry, the galaxy all wrong. Okay, 21. Save exactly as seen. So we saved it first as a FITS file. That's an astronomical file format for doing processing and real work. And then the PNG file is the one that's going to allow you to actually see exactly what we're seeing here on the screen. And this is the one you can download in 30 seconds. You can download them all if you want. Okay, so there's Measure 81 and Measure 82. All right, and we're going to now go back to our low light mode. All right, and there you see the stellar nurseries in there. So now let's do this, because as both Fantasy said and as Julie asked, we actually have, I'll do it this way. I'm going to take away our equatorial coordinates and bring in our coordinates here, because we're going to go up to the zenith. Now we're just looking at the horizon view, right? And right up here, okay, you'll see we have Auriga, we have the Flaming Star Nebula, we have a bunch of other things, And we also have the Pleiades up here, which is right here. And the Pleiades are literally right here, and they are sitting at an altitude, I should say an azimuth angle of 74 degrees from the horizon. 90 is the top, directly up, and it's 74 degrees up. So let's go and let's go check it out. Let's go look at the Pleiades. I don't know if you can hear. You probably can't hear the telescope. I think you can hear that complaint from the guiding program. Yeah, there it goes. There it is. It's heading up toward the... there it is, so we should see it. I know that doesn't look like much right now, but that's just because of the way the telescope's pointing. Okay, so we're going to do a 5-second photo here. There we are. And now we're going to move to the Pleiades directly. They'll be dead center. They're not far away. There we go. Let's start. Oh, this is a 5-second shot, by the way. And that's Alcyone in the center. And I'll go back to this mode here. We're just doing a 1-second photo. All right, and then from here, I want to take us to one of the stars in the Pleiades, which is really phenomenally and beautifully covered with dust. All right, I mean, they all are, okay? But Merope's Nebula is among the most beautiful. And so we're going to go look at Merope right now. So we're going to move from Alcyone, which is right here, okay, to Merope, which is right here. Now you don't see much, and what I'm going to do is I'm going to bring this up here because this is a little helper for me right here. This is what the axis of the telescope is at right now. Okay, so what it means is right about, let's do it this way, right about there. So if I want to move this up, okay, I can move it up. All right, and we're going to go right about there. Whoops, that's too much. Maybe not. We'll just come down a little bit. All right, a little more. Okay, so from here, what we're going to do now is we're going to take our photo, and the nebula is all throughout here. Now, based on the angle the telescope is sitting at, I just have to make sure that that's correct. So we'll take a 10-second shot first. And we're not going to stack it or anything. We're just going to take a 10-second shot to get the imagery straight. Oh, yeah. Okay, so here you can see the basic nebula. So this will be perfect. Okay, now we're going to do a 35-second photo here. And this 35-second photo is going to be stacked. And I'm going to fit the height of the... So this square here represents the entire field. Right? And it might be good if I actually get a star to guide on. There we go. If this first one works, that'll be fine. Otherwise, I'll just restart it. Okay, that looks like it might have worked. Now we'll get that down there. Oh yeah, look at... Beautiful. I could lower that down just a little bit, huh? I'm gonna probably do that. Okay, so this dust is amazing. All right, let me just do what I said I would do. I'm gonna bring Merope down just a little bit more. I don't want to lose too much of it. Okay. That should work. Okay. Then we do this again, and we're going to stop, reselect. Moved a little, as you can see. There we go. And go. Okay. Now we'll do a 35-second shot, and we can now start our stack. And of course it's going to fit. Here we are. So clear. A.A. Genost said, knew one of the people who worked at Mount Graham, Lucifer Observatory. Yeah, great name. And back in the early 1990s, asked him if they found Planet X. He did not want to talk about it, but did say, yeah, well, I have a feeling I understand why he didn't want to talk about it. It's controversial, and Planet X is not a planet the size of the Earth in any way, shape, or form. If anything, it's going to be a smaller planet, more the size of Pluto, actually, which is kind of, you know, the sad truth about it, actually. All right, let's do this. Yeah, there it comes. Yeah, so this is Merope with its beautiful, feathery, wispy, almost brushed dust clouds. These dust clouds are light years long, and as I said, they may extend all the way to Earth, and we may be embedded in them as well. The Pleiades are only 230 or 40 light years from us, so these stars will actually remember the size of the dark spiral arms in the galaxies, that those dark lanes, they're hundreds of light years long. So you could end up inside of one very easily, and maybe we are, and we've been looking out from inside one and never even realized it. So I think that's pretty cool, but that can mess everything up, because our distances are based on interstellar reddening and reddening of objects. And that reddening kind of gives us clues as their distance. And if we're inside of a dust cloud and don't know it's there, then the dust is reddening objects and making us think they're further than they might be. Yeah, this is a sticky problem for us, you know. So, yeah. Okay. Robert Thallium says they are hot. Yeah, these stars are very blue. They're type B stars, as in O and then B, A, F, G, K, M, in hottest and bluest to coolest and reddest. That's O, B, A, F, G, K, M, the spectral types or spectral classes. And then the types depend on what's called their luminosity class, which is a whole nother class which details the size of them. You can have a gigantic star like Antares, which is red, and its surface is cool, or you can have a small, tiny star which is red, and its surface is its surface is the same temperature as Antares, yet it's so much smaller because it has less output. So the small star that's the same temperature as the big star has a different luminosity class. Think of it as size, and effectively, the bigger the luminosity, the more different the luminosity class will be from a normal star, and that's what we see. So we'll let a few more of these. Wait a minute, we're actually getting some errors here. I only got one frame out of this altogether. Let me figure out why. I'm doing this, and I bet you this is... yeah, okay. Alright, so... not sure why that failed. If I turn it off, I bet you it'll work. Unless it couldn't align the frames. Yeah, it says it couldn't align the frames. Well, that's ridiculous. It sure can. We're still guiding just fine. It might be that we're getting some wind out there, and so that could cause it to be causing a problem. So let's try a gamble. Let's turn off aligned frames and let's just stack them on top of each other regardless. All right. So now they're going to come in, and if it's a little fuzzy or dash shaped, then we know that the wind has been causing a problem. All right. So there's our second one, and it looks okay. All right. So we'll get more good ones out of this. This program's doing the same work as this program, but this one has checks and balances that I was using, and I'm not allowing those checks and balances because we're getting a reasonable outcome. Look at that beautiful star. Look at that. And this little blue thing right here, it looks kind of like a artifact from the bright star. That's actually there. This is an artifact of the star, but that thing is actually there. It's a bright knot of dust. Yeah, I can hear wind through the microphone. I have a microphone out there, and I hear the wind. It's like listening to the Martian wind. Okay, let me catch up on the. Let's see. Laureate LDP says I'm really bad at star names. Okay, I see where you guys are in a conversation. All right. Okay. I'm reading. Nevitz Forever, how are you? Any vets? I assume the mass of that dust would dwarf the mass of the planet Earth. The dust is actually very, very low density, believe it or not. At some point, yes. Give you an example, like the dust you're seeing here, all right? When we look at dust in the interstellar medium, we're looking at dust that occupies maybe 30,000 atoms in the size of a sugar cube at its most. That's a dense interstellar dust cloud, a sugar cube, okay? Literally a sugar cube, cubic centimeter maybe, a little less, a little more, okay? But in general, sometimes there's only 30 atoms in a sugar cube space. Now, contrast that with the density of air that you have no trouble walking through, okay? Air density has 10 to the 19th or more atoms in it in a sugar cube size. So we're talking this unbelievably more atoms in a cubic centimeter of air than a cubic centimeter of space. See? So it would take many light years of that stuff to add up to the mass of the Earth, and that's what happens. Okay, this is working fine. Look at the beautiful detail in that cloud emerging, huh? Wow. Let's see if we can get Merope named here. There we go. And it's called Barnard's Merope Nebula, but we'll call it Merope Nebula M45. Right here. There we go. We'll set that target name. And we'll save it in the directory with its annotations, so you can actually go see this written with its actual definitions. All right, now we'll save it with 7. Save exactly as seen. Wow. Yeah, the Merope Nebula is beautiful. Okay, let's see what I'm missing here. Robert Daly, I'm glad you're enjoying it. Glad you are enjoying it, I meant. That's right, Fantasy, Antares, you're right. If you put Antares where the sun was, its orbit would go out beyond Jupiter's orbit. That's to say, its diameter would go out beyond Jupiter's orbit. So it's the same on the other side of the star, too. So if you can think about it, it took us several years for the Galileo probe, all right, to get to Jupiter. If we had the Galileo probe crossing the disk of Antares, it would have taken it several years to cross the disk of one star. All right, and that's moving really rapidly. So isn't that impressive? That's pretty cool. And Ronald says, ERT says, Mark, it's not as windy as it was a couple days ago. Yes, that's true. Yeah, you had some turbulent weather the other day. They actually had a thunderstorm come through there yesterday, I believe. I was checking. I saw it on the All Sky cam. It was just like, not the All Sky, but the one right above here. I can point that one anywhere around the property. Any Vets Forever says, thank you for explaining the sugar cube example. I'm always interested in scales, sizes, magnitudes. 30 atoms versus 10 to the 19th. Yeah, exactly. Toner Low, hey, how are you? Nice to see you. I wonder how long it takes a photon to escape the core of Antares. That's a very, very intelligent thing to say, Toner, because that's one of the things that I had to do in astronomy was I had to calculate photon escape times out of stars, and it was based on so many different things. When a light photon's emitted inside of a star, it can get stopped by something else, and then it would get redirected, and it might just zigzag around. And in some cases, it could take upwards of hundreds of thousands of years for a single photon to make it out of the star. Okay? In most cases, it can take a few hours. It could take, some days maybe for the photon to escape. But the interesting thing is that photons don't just stream out of the star. The ones that come out of the photosphere, yes, but the energy bundles, the energy packets that are coming out from inside the star, well, those are interacting with the entire stellar medium all around them, and they're heating it up tremendously. They're causing all kinds of changes. You see, boiling pot type things in the surface of the star. We see those on our sun. Those are called granules. Granules, granules. They're like little round hot spots. They look like dried mud in the desert. You see those little shaped areas, and they connect to each other. Well, think of that as the hot stuff rises up to the light part, and where the edges are, it goes back down through that. The cooler stuff sinks. It's like a boiling pot. Really, really fascinating. And so stars have an extremely complex physics. And for one of my projects, I literally built a star, and computationally in a computer. I said, okay, turn on the accelerator, and my star worked at all different levels, and I made a star kind of like the sun. So it was radiative in the core, and then as it comes out, there's a transition zone where it transitions to convection, like a boiling pot. Deep stuff inside is dredged up and brought to the surface and goes in a cycle, okay? And then the radiative envelope down below is where it radiates out. Then it hits the other stuff, and it gets shunted around and moved around, and finally it gets out. Now the things that do not suffer this impedance from the star are another special high energy particle called, who knows? We have deep minds that try to capture them. Put it in the chat if you know. High energy particles that don't get affected by other particles around them. They stream out of the sun. Thank you. That was it. And Yvette's, he's getting it. Neutrinos. That is correct. Well done. When we start doing giveaways, it'll be questions like that that will, get winners of binoculars and things. Not tonight, but we'll get there. So, neutrinos are very important because just before a star goes supernova, all right, a stream of neutrinos bursts through the core and heads out of the star. So before Betelgeuse goes supernova, and we're looking, we're not going to get surprised by it. We're looking for the neutrinos, as Fantasy also says, and these neutrinos will stream out of Betelgeuse, and what's happening is they are already signaling the demise of Betelgeuse. They're already saying that the supernova is underway deep beneath, and because Betelgeuse is so big, it's going to take many hours for that physical matter to rumble its way to the surface and break loose at the surface, destroying the star. And so, but the neutrinos are unstoppable, and they pass through the whole planet Earth without even stopping, unless we can trap one or two out of billions, and that's what we do. So if we see a stream of neutrinos come from Betelgeuse, we know that the supernova is underway, and all telescopes will be trained on it, including this one, if it's up. Now, if it's not, we may do daytime streams where we show people Betelgeuse during the day, because you will see it. Your eye. You'll look at it in the sky and say, what's that bright thing in the sky? That's the star Betelgeuse, having gone supernova. It'll be so bright that you'll see a new star in the sky. Just like the Chinese did in 1054 AD when they saw a bright star in Taurus that wasn't there before. And that bright star became known as a supernova remnant that we call Messier 1, or the Crab Nebula. So that's pretty cool. Star Traveler says, I'm sure I'll have clouds if and once Betelgeuse goes supernova. Yeah, okay. Well, it'll be bright for potentially 6 to 8 weeks before it starts to dim. Exactly, Robert Thallium. Like when the Crab Nebula exploded, it was visible to Chinese astronomers, although they had no idea in 1054 AD what they were looking at. Would you like to see the Crab Nebula? Because if you'd like to see it, I'll show it to you. We've got 21 here. That's good. I'll save that just like this. Save exactly as seen. If you guys want to see the Crab Nebula, a supernova remnant, the thing that the Chinese astronomers saw, I'll go to it right now and check it out. Julie Power says, it's incredible here in Florida tonight. It's not as incredible as this sky, honey. I'm kidding. Julie's a sweetheart. I've known her for a while. Good person. Okay, there's the Merope Nebula, and if you want to get these, just go to skytourlive.org, scroll down to Take Me to Cool Pictures, and read the instructions, and you can get there in less than 10 seconds, and in less than 30 seconds, that image will be up there. Okay, so let's now do this. Let's go into our low light mode, and let's actually fit the height here. And now we're going to go and let's go now. Crab Nebula is right near this, so we're going to just go right to it. Shouldn't be a problem. Yeah, and it's actually probably going to be one of the best views of it that we've had, because it's literally way high in the sky. So let's check it out, shall we? Okay. All right. Now we're going to go there. And I believe that's it right there. Okay, so let's come here and let's bring it down into the view. Yeah, you're going to like this. This is what you're going to see from 1054 AD. Again, like I said, I believe it's right there. What you're going to see is the stellar remnant that has moved out several light years since 1054 AD. Okay, we've been following it for over 100 years, and in that time, we've actually watched it expand with photographs. We've actually made, there's a movie out there, you can see the Crab Nebula expanding over about 100 years or so. It's really cool. All right, let's go get our guide star. All right, we should have a guide star. There we go. We're gonna do this. That's faint, but it's good. All right, this is just for a visual. It doesn't do anything to the quality of the camera. Okay, I think it's right there, but let's go see. Let me see if it knows. Actually, it's there. I can see it right now. Yeah, okay, it'll be there though. How do I know? Well, I sort of see it. Okay, now we're going to do a 30-second shot. All right. Okay, and it looks like it doesn't like that star, so I'm going to stop. Grab a new one. That's the one I want, and now we'll do it. That'll be better. Okay. So now we'll do this with a live stack, because like I said, it's going to be right about here in the image. It'll be bigger though. So this is the Crab Nebula. It's that remnant that was visible as another star in the sky. And then this object is what was left behind. And let's show it to you properly. Look at that. Now, what was left behind was what's called a pulsar. All right. A pulsar is a neutron star, and that neutron star is interesting because they're very, very hot, very, very small stars. You can see it right there. Okay, that's the pulsar. Now this is several thousand light years away, and you're seeing an object that is literally the size of Manhattan Island. It's only about 20 to 25 miles in diameter. Can you believe that? And it's thousands of light years away. That's how bright it is. Okay, let's pull this back a little. Let's color correct this. There we go. Look at that. All right. So now let's do this and pull it down a little softer. You can see now, you can see the filaments here. The red that you're seeing here, this is hydrogen. All right, hydrogen and neon and other elements that were made in the star, or the star was made with back when it was first formed. Part of the original stellar nebula from which it formed. And this object is one that is, well, I guess I'd have to say, it's one that is actually quite famous. And we're going to call this Crab Nebula. We're going to set that as the target. Save it. Okay. Oh, see that? Had a little wind burst came through. But not to fear. Oh, I can't unstack. How about that? Alright. I'm going to clear this and start over. I'm going to try using the full width half maximum and do that. Alright. And now let's see if we can actually get this to work. If we did 11, what happened there? Come on. All right, there we go. Now let's watch and see what we get. All right. Very nice. First frame was a little movement. There was a little movement in the first frame, so I hate to do this to you, but I'm going to do it again. All right, so this object, being several thousand light years away, is one that, again, was visible during the daytime sky for several months. And then when it faded away, what was left behind was this nebula, which the Chinese could never see. They never saw it. It was always just this object that was there and then gone. So they recorded another star in the sky for a period of time. So this object is also, like I said, that middle star in there is a pulsar the size of Manhattan Island, and you still see it because it's so bright. And it's only ever a point of light. So a very, very tiny point. Just amazing. All right. So what we look at is for a pulsar is the stellar remnant. Now, when a star like the sun dies, it swells into a red giant and then shrinks down to what's called a white dwarf. It sloughs off its outer layers by thermal pulses, they're called, and pushes them out, makes a little nebula, kind of like the Ring Nebula, kind of like the Helix Nebula, kind of like the Dumbbell Nebula, okay? And it pushes these out, pushes out the outer stuff it's made with. And that white dwarf takes billions upon billions of years to cool down. So that said, when we look at the next level up in the stellar game is for a star to not just swell up and then shrink down quietly like our sun will, but to be so massive that when it shuts down, everything shuts down immediately and the star collapses on itself. And we get that burst of neutrinos that I told you about hours before the actual visible light supernova. And then the star just obliterates itself when that explosion percolates out from the center and just goes and it literally destroys the star. All right. Well, in the case of a star that is like an O-type star or a B-type star, the supernova can leave behind a pulsar if it's a lower mass O or B star. And what that is a neutron star. Now, white dwarfs are held up by densely packed electrons, all right? And you can't pack them in any tighter. And so you have this electron pressure pushing outward, and it holds the star up. Now, if you had more mass, you could collapse it further. So if a star is a higher mass, it could collapse further to a neutron star. And that's the next level like we're seeing here, right? The neutron star, when it collapses, now it's neutrons that are packed so tightly together you can't pack in anymore. And that very resistance to being crushed keeps the star stable and held up. But it's so tightly packed and has so much gravity in it that if you took a teaspoon of material and you could somehow weigh it with Earth standards, a teaspoon would weigh several billion tons. Can you believe it? A teaspoon. That's a lot, you know. So that said, this is looking pretty. Look at that. And it's almost right overhead. So this is probably the best view we're going to get of it. Okay. So that said, the neutron star is resistant to being crushed any further. Now, if it's even more massive, specifically a little more than 2.4 times the mass of the sun in its center core, okay, the core we're talking about now, then it can collapse further into a black hole. And the black hole is kind of where real space ends and the unknown world of what's inside a black hole begins. Now, if you see any popular culture takes on the universe, you'll see that there's one theory that says we are inside a black hole, you know, megalithic proportions. Now, is that true? You know, maybe, but I don't know about that. Donald Hunter says, that's no neutron star, that's a battle station. Yeah, right? No kidding. This is coming out gorgeous. Look at that. Really is the best photo we've taken of it ever. Nice. Yeah. So neutron stars, very strange animals. Now, what this one is a pulsar. They also spin very rapidly because when the supernova blows up, okay, there's differential forces that are applied on that core from that explosion because it doesn't go the same way in all directions. And so that imparts a spin on the core. So neutron stars typically can have some very fast spinning. Sometimes it's very slow, but sometimes it's extremely fast. And if there is a hot spot on it of material, then as that material swings around toward us, we see a flash, okay? Whether in the radio spectrum or in the visual spectrum. And you'll see it's like, so if it's going 10 times a minute ago, you know, and then a few seconds later, all right? So, but that said, pulsars tend to spin very, very quickly. And this one right here, okay, I gotta point out where it is because I'm not sure you can see it. It's this guy right there. See that little guy right there? Yeah, that's a pulsar. And what you're not seeing, okay, what you're not seeing is you're not seeing it spin 33 times per second. That's right, per second. So when we talk about neutron stars, we talk about their spin rates as a frequency. Now, you might say, what? What's that mean? It means that there's a frequency, how many cycles per second? And there's 33 for this one. And by the way, that's kind of slow for a pulsar, believe it or not. That is a remnant neutron star from a supernova. There's another pulsar out there that goes around literally, and I'm not kidding, you can look it up, well over 700 times per second. Per second. Right? Per second. Is that amazing? And so that makes for an extremely fast rotation rate, and that means there's a lot. You can't imagine the forces at play inside a pulsar. Now, they also give off a tremendous amount of energy, right? There's a lot of radiation coming from this pulsar. And when we look at the Crab pulsar, one of the things we see when we look at this Crab pulsar, which is right there, is if we can slow down a video of it, we literally watch it blinking. And there's a video of it doing that. 33 times per second. They slow it down, right? They do several thousand frames per second, and so you'll see it blinking, okay? And so that you can actually see that it's blinking, and when the hot spot flashes us, again, thousands of miles away, the size of Manhattan Island. It just gets deeper and deeper and deeper, doesn't it? Isn't it incredible? So it's amazing, but that's how pulsars work. And that is just one particular stellar death, right? They can go to a pulsar. They could just go to neutron stars, which again are very dense. Basically, they're literally as hard as a billiard ball on their surface. They're not doing fusion anymore, and neither is a white dwarf. Okay, stars do fusion, but when they go to white dwarf stage, when they go to neutron star stage, they're not doing fusion any longer. That's long gone, and they never will again. And so what we'll see is that they're just going to, sit there and be a very, very hot object that's going to cool over many billions of years. A neutron star will cool as well because it's giving off energy, right? And it's not taking in any energy, it's giving off energy. So over time, it'll cool. And the amount of time it would take a typical neutron star to cool is longer than the universe has been in existence already. So there aren't any neutron stars that have formed in our universe that have cooled to the point where we can't see them anymore. Neither have we seen a white dwarf that's cooled to the point where we can't see it anymore. Theoretically, it'd be called a black dwarf. But we've never seen any black dwarfs. Isn't that cool? Yeah. This is beautiful. This is coming out gorgeous. Now, you'll notice that the star in the middle has a little oblong nature to it, and that's because it's not one star. There's actually a second star in there. See it? Yeah, but that bigger one is the pulsar, just so you know. Let's go to our histogram. And let's try to pull in a little more brightness. And add in... Now, if we go really far, well, then we're pushing and it gets extremely bright. But the purpose of it is to show some of the extremity detail that's out here, right? And so we can focus on trying to bring that out with our photos. Like when they come back, you'll see that there's this thing right here, this loop right here. If we want to show that, what we have to do is just keep taking photographs until we can see it more clearly. Now, right now, it's pretty good. Let me see if I can, if color correcting will work. Yeah, color correcting helps because you can see more of the red glow of hydrogen here and in here, and you see the greenish teal glow of oxygen in here. All right, so hydrogen is the most populous element in the entire universe, right? The next one is helium, and there's helium in here. And the next one after that, believe it or not, third most populous element is oxygen, believe it or not. And oxygen glows greenish blue when it's excited by hot temperatures. And that little tiny pulsar in there is so hot that it's actually ionizing all the atoms in this envelope around it. And then that ionization causes the atoms to glow and causes glow, right? Technically what's happening is the electrons are pushed off the atom, ionization, so now it's just the nucleus, and then they lose energy when they leave the atom, they bounce around, hit other things, and then they come back into that atom or another one, and they drop down to various discrete levels in an atom. Now they're very discrete, and we've learned these discrete levels for hydrogen and other elements, which led to the science of quantum mechanics. Quantum being discrete levels. And so these quanta, these quantum levels within an atom, when the electrons drop into them, they give off certain colors of light. Now why? Because they've gained energy. Okay, they absorbed light energy when they left, and then they give it back when they come back in. So when they bounce back down into an atom, they go to many different states, but the predominant one is the one that we see more commonly, like hydrogen. Hydrogen, all right, can drop into an atom again. The hydrogen electron can drop back into the atom, and when it drops back into an atom, it can go to a variety of levels. Okay, however, the most prominent level that it drops to is one called n equals 2, the second level, so to speak, and that one delivers a red glow. So whereas we see other types of glows from hydrogen, the red one is by far the most prolific one. Same thing with oxygen, so that's why we see it like this, you know. So, hey there, Garlago. Thank you, man. That's so kind. Thank you so much. Thank you so much. If you folks are interested, you can see up top, you can become a Patreon member and help us out. I take no money for what I do with Skytour Livestream. That was very clear from the very beginning. I wasn't going to do that because this is not a money grab for me. This is a passion grab, right? It's a passionate thing because as an astronomer, all we have are our tools. So every single dime given to us goes to furthering and helping us get better tools, you know, and helping. I mean, things go bad too. So when we repair, it costs money, you know, and sometimes we eat the cost, you know. Sometimes Marianne pays for it, and sometimes you know, I donate equipment and so forth. But it's all because we want to bring a level of astronomy education to the world that has never actually been in practice before. And this is a free science class to you. You're learning about neutrinos, you're learning about ionization states, you're learning about recombination, where the electron jumps back into the atom and gives off the specific lights. These things are all interesting things that you would never find out about in a community college science class. You know, they would say, oh, the red glows hydrogen. Why? Well, because it's red glows hydrogen. You probably wouldn't get the same caliber. I mean, and not to diss the community colleges. I was thinking of teaching in one myself, just to help pursue that. But I can't because it would take me away from this. We have 2 observatories, and we're looking at potentially getting a 3rd one. And we have potentially 2 sites in Colorado that we might have. We had one a couple months ago, but now we might have a 2nd site in Colorado that might be good for us as well. But either way, we're in no rush. We're not going to rush anything. We're not going to grow too quickly. We're going to just get what we need when we need it, and we're going to move forward and take you with us, whether you like it or not. Hopefully you like it. So that said, I'm looking forward to showing you more. Now, you really should, if you want, look up the Crab Nebula, Messier 1, and look up time-lapse Crab Nebula in Google, and you will find this beautiful expanding time-lapse. And of course, when Hubble started getting involved, this is prior to James Webb, you started to see much more detail in the other images, but you got to check it out. It's really a fascinating thing to see. Okay, so we're at 31 images here. We're gonna save this here. Really pretty. I'm glad that we thought of this. Whoever, I think I might have suggested it, but I think I got it from one of you guys. So thanks for that. Son of Orion, how you doing? Long time no see. Ross and Crystal tuning in. Nice, guys. It's so good to see you guys. So nice. And then Donald Kunzer says, I love watching Red Dwarf. Did I ever tell you I must have. I did. I told you my Red Dwarf story, right? I mean, most of you know I have a visual effects company that I started back in the early 90s. And one of the jobs I did was I had to go to England to do a submarine show, because I've become sort of a fixture in the underwater world for submarines and their technology, and so the Navy will use me for a variety of things. Well, anyway, I did a submarine miniseries over in London, and when I was in the in North Acton in BBC Centre, I was in the model shop. I was walking over a plywood floor covering. It was a piece of plywood on the floor. And I asked the guy, "Hey, Gene, what's that?" And he goes, "Oh, that's a hole covering a hole in our floor." I said, "You can fall through to the next floor down?" "Oh, yeah." He says, "So be careful." I went, "It's loose?" "Yeah." And he lifts it up, and I see it's blue. And I went, "Wow, that looks like the TARDIS from Doctor Who." He goes, "Oh, yeah, it is." "What?" It was one of the walls of the TARDIS model for Doctor Who. I was like, "Oh, my gosh." They're walking on TV history. I couldn't believe it. And he says, "Oh yeah, come here. We got all that crap over here." "Crap?" I says, "Not crap." I walk into a room. He shows me a storage room full of Daleks, full of different versions of the TARDIS, full of interior set pieces, exterior set pieces, costumes. I was blown away. Little models, big models, tiny Daleks, big Daleks. It was really, really impressive. And so I was working on a Trieste model. Trieste was a bathyscaphe, a deep diving submarine that went down to the bottom of the Marianas Trench with Auguste Piegard. All right. Well, anyway, and we're recreating that whole sequence and creating a model that would drop to an ocean floor, kick up dust. It was really cool. It worked well. The show was called Nautilus. Well, while I was at this cabinet looking for paintbrushes, I opened up the cabinet, and I must have pulled the cabinet, and a model on the top shelf fell down in my hands. It was the Red Dwarf model, the actual filming model for the ship. Red Dwarf is in my hands. It was this big. It was probably a foot long, and that's British. They never put a whole lot of thought into depth of field and things like that with their stuff. So this little model falls in my hands, and the guy comes over and says, "Oh, you almost broke the Red Dwarf." I go, This is a classic model." He goes, "Yeah, it's just a piece of junk to us. We're going to throw it away eventually." I said, Can I have it?" And he goes, No, put it back. "Okay, we'll talk about it later." Okay. I thought about that Red Dwarf model the whole time, and when we left, I said, So what did they say? They say I could take that red dwarf? And he goes, well, if you want to not get paid for the production, they said you can have the red dwarf model. No, I need to pay. All right, well, then you can't have the red dwarf. Okay. And so I never saw it again. That's the rest of the story. I didn't tell you a lot of it before. So that was pretty cool. Anyway, this has gotten us to 39. We're going to go to 40 and stop there. Once again, the Garlago, thank you so much. That was very kind of you for that donation. Fantasy says, this is way better than the National Fixed League. Yeah. Well, you know, I guess my understanding is they had 2 half times, I guess. So what do we got here? Donald Kunzer says, BBC has no respect for its shows. Monty Python had to buy all their shows. You're right. The Monty Python team, they had lots of trouble with the BBC. You're absolutely right. They did. Yeah. And Dave in Bangor, Maine, what's going on, man? Haven't seen you here before. Dean Bostador, I see you're back. Nice to see you. Mr. Django, good to see you as well. JSCO, nice to see you. Robert Waters, good to see you as well. Very cool. If I missed anybody, send a message and let me know. I want to say hi to you. You know, Son of Orion says he loves it. That's good. Dave in Bangor. I'm not going to ask where you're from. I kind of know. Yeah. And Son of Orion says, hey, Mark, I just made F2 recently. You mean F2 as in focal ratio? Donald Kunzer says, don't get me started about the 60s Doctor Who shows. Oh, I know. They were terrible. Dave Bangor says, new subscriber. Fantastic, brother. Welcome to the family, man. As you can see, this is what we do. We have fun. We talk. I usually have a co-host, Daryl. He's not here tonight. It's Super Bowl night, so, I didn't want to ask him and make him feel bad if I, because he's probably watching the Pats, So, in any case, I hope you guys are having a good time as well, those that haven't said anything. So, I'm really hopeful that this will be a beautiful shot that we can process and show you the finished one. I'm going to save this, and then we'll save it 45 and then move on to the next object. Toner Low says, looks like there'll be a Europa transition tonight within the hour. Alright, well, let's see if it's within the hour. Do we want to go spend the time? Because the telescope will show that well. Sounds like Toner's asking us to go to Jupiter. You tell me, guys, should we go look at Jupiter? I mean, I always take requests when it comes to this stuff. I'm never without things to do. All right. Robert, good to be seen. Oh, Star Traveler says, love Jupiter. All right, well, let's see. Gemini. Yeah, that's where Jupiter is, man. Let's go check it out. There's so much to see out here, man. But Jupiter is about 67, 68 degrees up in the sky. We can check it out. Let's first kick this off, because we don't need this now. And let's now come back here to Jupiter's and do that. Now the telescope, you watch it move, it's going to head on over a bit, and we're going to see it. We're going to do our 1 second shot here. Yeah, it's going to do a rollover meridian flip maneuver here to get to the other side. There it goes. It's going to be pretty high in the sky, too, so it's going to be pointing up. This is the infrared sensor light on the telescope. I'm sorry, on the camera. The security camera, that is. There it is. Just went by. Okay. Alright, it just went by. So what that means is we can just go grab it real quick. Alright, so now Jupiter will come back in and go right there. I predict right there. Hang on. There we go. Not done yet. It's gonna get in there. It's gonna keep coming. I know how this works. So it's gonna stop right about there. I should stop. Bam. There we go. Okay. So now, you can see, let's drop the gain down to 0. And let's drop the exposure. Let's drop this, actually. Let's drop this processing. And that's the disk we can see. But if you want to see the, Jupiter's cloud bands, then we got to go to really low. Let's do this. 70, you can already see them. 140, here we are. Okay, now there's a number of ways. All right, so this is just the face of Jupiter right here. And what we can do, we actually have a way to actually do this. We can actually process this to show you more detail. Look at that. This is a live shot. Okay. Look at that. You can see a lot of detail in the cloud bands here. And you see the red spots on the other side of the planet. We can't see it from here at this point. But you're saying, let's see, if you're saying Europa is going to transit Jupiter within the hour, let's see if we can find it. Okay. First things first. We'll just save this to a 16-bit. Let me first of all just say Jupiter. And let's save it to a 16-bit TIFF, which is something you can open with your computers, no problem. Let's actually adjust the brightness and color to make it more proper. That looks good. And yeah, okay. All right, and let's save one more time, and then let's go out and let's go bright enough so we can actually see the moons. All right, so what we're going to do is we have to overexpose Jupiter to see the moons. All right, so let's now come in here, zoom in on Jupiter. I'm going to show you another object in Gemini here shortly. And there's Ganymede, Callisto. And Europa must be behind Jupiter. Is that it? Is that true? I guess it's behind Jupiter now. And when does it come out? I don't know that. Yeah, this moon up here, okay? This moon up, let's see, which way are we angled here? Let's do this. Let's do this. Okay, so this is Io, right? And this is Callisto, and this is Ganymede, if I read this right. It's a little, we're rotated around. Okay, so it's Ganymede and then Callisto, right? Okay. Yeah, so this is Ganymede, the largest moon in the solar system, and then this is Callisto. If Ganymede was circling the sun by itself, it would be considered a planet. That's how big this is. Pretty cool. And Europa must be behind it right now. And so what I would do is do this and drop this down, right? So we can't really... I'm not sure when it's going to come out. Donald Kunzer's asking if that's the moons. Yeah, which I had just mentioned, which I think you saw. Okay, this is Callisto right here. This is Ganymede. And this is Io. If you look carefully, if we take a photo, let's take just a plain photo at, say, 2 seconds. And Jupiter will be very bright. But I want you to look at these moons. I want to show you why. Okay, so here is a coming up with a 2-second photo here. I'm going to raise this up a bit and then just like this. Just got to be careful with this. It's not showing too well tonight, but Io will look orange typically. Just like when we look at Saturn and we see Titan, we'll see Titan as orange. And this is Ganymede. Ganymede actually has a bluish green cast to it because the real moon does as well. So as we drop it down, it's hard to see. It's hard to see. But again, it has a bright reflectivity because it's a big moon. Callisto is smaller. All right, and Io is smaller still. But they're bright, so we can see them. So how does anybody know? Does anybody know what the transit time is going to be? Actually, if you said it's within the hour, I can actually do something. I can accelerate time and watch it. As it moves through the sky. Okay, there it is. There it is. So it's going to come out on the side. Oh, that's not good. Let's go to now. Okay. So one more time. It's going to come out on the side of Io. All right. And let's slow it down. Here comes Europa. Okay, you see it's labeled. And let's find out when it's coming out and see if it's a time that we can do. Yeah, I see it. Here it comes. And pow. It just starts coming out right there. Okay. And that will be at time 10:46 48. 10:46. That's going to be another hour. Okay, we won't probably wait for that, to be honest. But we'll catch that another point. I do want to also make sure of my timing. Let's go here and do this. Get the correct time again. And okay, it's off by an hour. It currently thinks it's 8:21. It's not. The time zone must be off on the program. All right, so it won't be that long before we actually see Europa come out. But do you want to stare at Jupiter as a blank disk for the next half hour? I kind of appreciate and would respect that. It's going to come out right there. When it actually does, it's going to come out right here. What we can do, it's going to be very bright. So if we can drop down the brightness a little bit, right, it'll be brighter than Io. but it's going to just come out right there. It's probably about here. So it's going to take it a little while. Okay. It's going to take a little while. Well, let's do one thing. Let's, we're down, we have a gain of 0. I'm going to drop us down to here, and let's do another stack. As we get more, you'll see this roughness go away. We're stacking 100 images right now. See, we're doing 23, 24, 25, 26. Yep. Let's reset all the processing. Let's do it again. All right. All right, let's do this. Get the fine detail in there. That's nice. And to denoise it, if we did this, you'll see that it kind of blurs it a little. So I tend not to do that one. This is a level 3 detail level. Yeah, it still looks very nice. See, obviously too much, right? And let's do fine detail a little more. Level 1 detail. There we go. So you can see a lot of detail in there. A lot of detail in that planet. We can see the blue pole areas that Juno has been looking at, and Jupiter, which is kind of cool. You know, really neat. This is a stack of 100 images. It looks black and white, but only because of the way I did these guys. If we want to add more color, I mean, I could. But actually, saturation could just get, oops, sorry. Saturation could just get way out of hand, see? Yeah, that's crazy. So saturation at this level is right there is good. You can see the brown bands. Very nice. Very cool. Save that one too. We'll clear it and do it again. Take fine down. Donald Kunzer says, Mark, how close can we get to Jupiter? Can it fill the screen? No, this Jupiter is small in the sky, so we would not be able to do that. We don't see the red spot yet, I don't believe. Let's go to the planetarium program here, because I believe it'll show us the red spot, and I don't see it. So it's on the other side of the planet right now. So we can just zoom in. Okay, this is 106%. This is 100% of the on the sensor right now. But to give you an idea of just how big the sensor is, let's fit the height so you can see how big Jupiter is in the frame. So here's the whole frame, and that's how big Jupiter is on it. So we're actually zooming in quite a lot here. So we can fill the frame with it, but it's it doesn't really help us too much, you know. Now what we're doing is we're actually let me see if denoising gets rid of a lot of stuff. Yeah, denoising gets rid of stuff, but it also makes it blurry. So we want some denoising, but not a lot. I could do this, but let's try this function. Yeah, no. Yeah, okay. Let's reset the stack, do it again. And take down the denoising because we don't want to lose detail. We do want some fine detail though. Okay, right about there. And this will be too much. Yeah. All right. It's usually you're gonna stay. You want this to be kind of like a curve like this. And we're gonna basically just pull a little more out there. Yeah. See, it takes time to respond. So we back out of that a little. There you go. Fine. That's pretty good though. And I don't think if we come back, let's do this and overexpose. We still don't have Europa coming out. Thank you for pointing out though that an eclipse was in the making. I didn't realize there was. But I don't want to, we're going to end up waiting for it too long, I think. So we will have to come back to it. And hopefully not miss it. But let's go check out something else while we're in the process. All right, and right near it in Gemini is this really cool planetary nebula. All right, it's called the Eskimo, and you got to see this thing. Yeah, I don't think you've ever seen a nebula like this one. All right, so what we're going to do is, yeah, it's going to move in. And we're going to go just to our, we're going to change the time here, and we're going to go do this. There you go. So you're going to see this. This has a central star, which is a white dwarf, and then that's a star that's expanded and shrunk down, kind of like the sun will do. And then there has an outer shell, and this outer shell is thicker than the furthest most shell, which is two different types of expelling of material. It's mostly oxygen. Again, oxygen, third most abundant element in the universe. It makes total sense to see. And so here we go. Let's leave it right here, and let's do a 25-second shot of this. Before we do that, let's do a few things. We're going to increase our gain, which is at 0 right now. We're going to put it up to 150. That'll allow us to. It's what's called. It's almost something called unity gain. Unity gain's 100 for this camera. So that's the one that has the best noise ratio. I always push those because I can get rid of the noise, so I kind of cheat. But why not? It looks good. Okay, and now let's do that 25 seconds, and let's grab a star in here. That's what the 25-second shot looks like, by the way, before stacking. So what I'm going to do is grab a star here, and then we're going to guide on that star. That's what I thought it was going to take right there. Okay, that's a good star. Okay, and I'm actually going to change this to 15 seconds, because we're going to be stacking it. And I'll be able to, because of the high dynamic range, we'll be able to get to the most dim details without, losing other details. And boom, and we're going to get rid of this. All right, so now that doesn't look very exciting, but I'm going to move this here. And now what I'm going to do is take this mid-level value and bring it all the way down here. Okay, so we're going to take this all the way down here. And now look at that. Now, if you look carefully, you can see there's a central star. There's a real specific sphere. That's a sphere of material around that central star. And then out here, you'll notice that there's actually tendrils, radial tendrils sticking out. So this is called the Eskimo for this very reason. Okay, so let's do a color correction. You can see the bluish green of the teal oxygen nebula. You can see bright and dark areas in this outer area. That's an outer sphere that has been pushed out over time. It's not a ring or a flat, it's an actual sphere. To understand how that works, and why you see the sphere and it looks like you see through the middle, it's like this. If my fingers represent this gas cloud, remember, this stuff is not dense. It's low density stuff, but just a lot of it. It goes out about a light year or more. So as you see my hands here, you can see through my fingers. Okay? You can see through my fingers here, but as I get to here, you can't see through my fingers. Now the fingers haven't moved, but you can see through them here. So from the front and the back, you can see through them. From the sides, you can't. Well, that's what this is. Okay? This is the sides from our vantage point, and the sides from our vantage point. But from the front and the back, you can actually see right through. So that's why these appear this way. This will look this way no matter how you look at it from any other angle in space. Okay? No matter where you look at it from space, it's going to look like this. Alright? So that's pretty neat. So we have a beautiful planetary nebula. Let's grab its name. Okay, it's called the Eskimo Nebula. Right, and we're going to set that as the target and save with annotations. So if you ever want to look at that picture, you can say, what was that thing again? It'll be in the title as well, because we have it up here in the title. All right, so now we've got 10 frames. All right, and if I move this to the left, we'll highlight a little bit more of the outside detail. All right, but we may lose some of the inside detail. And that, of course, is precisely because we are over brightening that brighter central region. But this is what you do in order to see the light and dark areas around this fringed area here. Okay, so that's not so bad. But now you can see what looks like another ring of material in here that's brighter. Again, this is why it's called the Eskimo. Let's see if we can enhance this a little bit. I'm going to increase the radius of sharpening, and now you can see that we've got more dark definition in here. We're going to increase the amount now. Let's go to this. Oh yeah, now look. Now you can actually see very, very detailed inside this specific object here. Nice. I can drop this down a little bit now. So without it, it'll look like this. Alright, so this is without any sharpening. It's kind of hard to see. But now if we add that sharpening in there, watch. Now we get more distinct detail in there. So this is the Eskimo Nebula. You can see these radial spokes basically of a wheel sticking out. Those are stuff coming at you, going to the sides, going behind you. It's all due to the outflow from this particular white dwarf star. And the white dwarf is in there. Now you can still see that this, we're not seeing the star particularly, we're actually seeing a greenish blue object in there. Well, that greenish blue object is the white dwarf surrounded by yet another closed shell. of material. So at minimum, we're seeing, you know, what looks like 3 shells. We're seeing this one, which was ejected most recently, and that's that inner one surrounding the star very closely. Then we see a second one here, and a third one, which was ejected first. So this one was first, this one was second, and then this one was third. And they're all expanding outward over time. So that's the Eskimo. It looks beautiful. Yeah, Robert Waters says transit began at 9:34 Eastern. Yeah, that was just 30 minutes after we started. It's now 11:20 Eastern. When does it emerge from transit? It looked like it might have been it looked like it might have been closer to midnight for us. Donald Kunzer, ah-oo, werewolf of Io. Ah-oo, bum, 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 ba-da, bum, bum. I like that song, Werewolf of London. Alright, so we got 24 of these. That's good enough. Excellent. Save exactly as seen. So we saw galaxies tonight, two galaxies. We saw a nebula around the Pleiades stars. And let's see, let's put this up here. We saw the Eskimo Nebula. We saw the Crab Nebula. Let's see if we can do an encore with something, huh? All right. It says Europa's shadow will start to cross the face of Jupiter at 11:20 EST and remain visible for several hours. All right, well, let's go look. Let's go see if we can see it. There we go. Back to the Jupe. Back to the Jupe. Hey, look out for the Jupe. Alright. Let's go down to 0 gain to get the lowest noise possible. Let's drop this out. And go see, because it's going to come out on this side. This is Io. This is Ganymede. And Callisto's out there. Let's go see. Let's drop this down. Let's go to 250 milliseconds. Okay, so we can barely see at the edge, at the limb, and I don't see anything yet. But I can move this over to get us just a little more brightness in the moon. So we're looking for an object to come out right about there, in line with these. And so tell me, how long it's going to be before it comes out. Now, if I go back to this, first things first, let me move this over so we can still see it when I bring up this. And let's center up. And let's do this. Alright, so let's move forward in time. Actually, let's go back to this for 1 second. Okay, the time in there is an hour earlier, so whatever the time is that we see, we're going to add an hour to it. We should see. I see Europa right there. I can see the marking for it. And it's coming. You can see right there. That's Europa. If you're not on 1080p, you need to be. Okay. And 2143. Okay, let's go to there. Alright, Europa's coming out. You can see it right there. Here it comes. Oops. Hey, get in there. Okay, wait a minute. Get Jupiter in there again. Come on. That's better. Alright, 2234. Michael Hedrick, welcome back from work. The sculptor is kind of low fantasy. Oh. Okay, so this is where Europa comes out. Right here. Alright, so there it is. And that's it. Time 10:42 in here, but we know that the time here is an hour off. So that means that the time is actually let's see, 10:42, 9:20. We're looks like we're an hour off, so we're probably about 15 minutes from it coming out. Okay, well, that's what it is right now. Yeah, we're a little over rambunctious, aren't we? Yes. I think we're a little bright on this too. That's more like it. And let's do this and this and this. Just think of the sheer size of this planet. Like 87,000 miles across compared to 8,000 miles for us. And Jupiter does have a ring. We cannot see it from Earth easily. Airborne observatories can see it. Let's reset the stack here. That's really pretty. I'm not. Yeah, I'm actually. I hate to say it, guys, but I'm gonna jump off this object because we really need to see a better quality object. And I'm not actually showing it to you right now, so I'm not sure when we can expect to see this guy, but yeah, it's 61 degrees, Ronald. Rub it in. It was minus 19 here yesterday evening. Yes, minus 19. Okay, let's see here now. But hey, you know, you came from Minnesota. You know, so that's pretty good. All right, let's come back here. Let's do this. This, I mean. Yeah, Europa's gonna be a while according to this. Okay, let's pull out of this. And we did the Eskimo. Oh, you know what? While we're here, and it'll show very, very nicely. You know, I haven't tried to look at this with this telescope, and the field of view is going to be this guy right here. This is the field of view. So I'm going to try to find this. This is another supernova remnant. Okay. And let's see where the telescope is going. Here we are. And we should see a star. Alright. And let's see if it can take us exactly to the spot that I want to be in. Okay, so now it will. It's literally just almost there. Okay. All right, now we're going to check out. This is the Jellyfish Nebula. It's a supernova remnant, and quite the remnant it is, I have to say. All right, so let's grab our star. Perfect star. That's beautiful. That's perfect. Nice pointy histogram. That's good. All right. So now we're going to go up the gain. We're going to go to 200. All right. And then we're going to take this out. Let's see if it knows what's here. It may not. It knows where it is, but it doesn't know that there's an object here. So I will have to put this in, assuming we can see it well. If we can't see it well, then we'll just move on. But this should be probably a 55-second shot. We got our star going. That's good. So for 55 seconds, we're going to be capturing this. Yeah, and we're going to fit the height for the moment. So we saw the Crab Nebula, and this is now going to be a image of another supernova remnant, which is kind of near it, which is kind of cool. C&D boy, how you doing, Bob? Good to see you, man. Let's make sure this came in right. This should look pretty. It should be a nice arc through the field. Let's see what we got. Oh yeah, look at that. So we're gonna get rid of this. Oh yeah, look at this. What a beautiful arc this is. Let's do that and do that. So we're looking at a portion of this supernova remnant. First time I viewed it with this telescope. It looks stunning, actually. focus is great. Wow. I could even have gone up to 250, but I don't want too much noise in there. Marco's with us. How you doing, brother? Good to see you. Hey, brother. Lori at LDP says, that's a lot of frozen engine blocks for Connecticut. Yeah, you know what's weird? Gasoline freezes at minus 40. And I was looking to see where there was any kind of minus 40 temperatures. Not in Connecticut, but at what used to be called Barrow, Alaska. It now has a full Inuit name, which I can't recall. But Barrow was really, really cold. Much colder, actually, than Antarctica, which is interesting. Because, currently, because Antarctica is actually in its summer. I had a friend who was the air traffic controller at McMurdo. So the runways were ice, were the ocean ice. So the ice runways, that's where all the planes land. And it's all ice. So you're landing on the ocean, but it's frozen, which is cool. And the interesting thing is that the ice fields of McMurdo, on a day that they considered warm, were negative 25 when you're outside. Minus 25 was a warm day to them. The temperature can go, in this winter to minus 80. So things like gasoline, that's 40 degrees beyond its freezing temperature. So you have to have anything stored outside that needs gas is going to have a heater on it that will keep the gas from gelling up and freezing. Just kind of weird, Look at this beautiful supernova remnant. We're just seeing a small portion of it, but I'm loving this. This is great. This is really coming out pretty. Let's go here. Again, if you notice our window here, the writing is upside down. So you have to flip it over to see this. Okay, and that's just what we're seeing here. Right? So it's this full in here, and we're going to be let me just center on that star, because that's where we are. Yeah. So that's what we're looking at right there. Boy, look at this. Let's bring some detail in here, because we can. Look at that. That's something else. There we go. Look at that. You see how we can play with the data to actually get lots of detail? We can pull this up the curve more to increase the contrast between the background of space and the supernova remnant. Look at this. Oh. We can see what else is there by over-processing. So over here, I'm going to over-process right now. Give that a shot. Watch this. Boom. So we see there's more stuff in here that will become readily apparent as we continue to expose. Neat, man. Yeah, Ronald says they had several years of negative 50. Yeah, well, that freezes gasoline, man. N.E. Vets says, gasoline sherbet. Yeah, that's right. Thanks, Bob, for putting those links up. Very kind. Hi, Sherry. How are you? Nice to see you. Thank you for the Shuttle Challenger anniversary there. And it was precisely because of cold weather that the O-rings did not contain the hot gases. Morton thiacol was definitely supposed to be put on a chopping block for that. Okay, so this is going to be jellyfish, nebula, segment. This is 6, and I'll say save. Save as seen. And then let's move this in some more. Oh yeah, look. And the other thing too is, like I said, make sure you guys have 1080p selected, so you can see all this detail on here, okay? Because if you don't get anything out of it. And we have Pookerson, first time viewer here. This is so cool. Many thanks for sharing. Hey man, thanks for joining. Do subscribe. It's all free, you know. And when we save these photos, like I'm doing right now, watch, I'll hit save, and you see a label across the top says Fitz file's been saved. Well, that's a scientific file. But if you want the real pretty file like this, then we do a save of that, and this is what is available to you in our directory for you. You can go grab it. It'll be up there within 30 seconds of taking the picture. And you'll be able to download them and enjoy them anytime you want. And that goes for all the imagery that we've taken. So if you go through that server that is at skytourlive.org, you can wade through and see all the other things we've taken pictures of. So that's pretty cool. So do enjoy. And as we're at 8. Look at that. That is pretty, huh? Really pretty. So I can actually take this and move it right near that curve. Get it as dark as possible. All right. Very nice. Yeah, I haven't done this, like I said, with this telescope, so this is really coming out pretty. Well, Pookerson, I'm glad you joined, came in. I hope you subscribed. It doesn't cost anything. If you want to support us, you certainly can. Well, thank you again there, Son of Orion, man. Thank you, brother. Thank you so much. I was about to say, before you sent that in, that anyone who donates $25 automatically will get a t-shirt that says "I need my space" on the back and shows all the planets, including Pluto. And then on the front, it has a skytourlive.org logo for our nonprofit. And as I said, all that money goes to just getting better equipment and updates and upkeep. We do not actually take anything for this ourselves. I consider that irresponsible. But thank you, Son of Orion. It's very kind. So I'm thinking that this is going to be one of the last objects, if not the last object. I gotta look and see. We're digging into this one little section of this. It's a vast area. We're that close to the Monkey Head Nebula. We could go here too. We're only going to see a portion of it, but I think we should see this portion of it. Okay, one more. We'll do one more. Alright, so we'll get there in a sec. First of all, let me color correct this. There we go. Look at that. We're going to do 12 out of this guy. And that'll be right now. There it is, 12. Beautiful. Never done it before. This one's good. Really pretty. Okay, saved, and that saves our FITS file, the astronomical file, and it will save the PNG file, so you can get this exact picture for free. All right, and now let's go and take ourselves to our low light mode, so we can now head over to the Monkey Head Nebula as our last object for the evening. And to do that, we're gonna actually come over here. See, that's where we're going, right there. Alright, so the telescope is gonna just head on down there. There we are. Yes, I know. I have to stop you. Okay. And let's get... we have some stars we can use. Good. And now, you can even see a little bit of the monkey head there. Let's see what we can expect for our image. So it's going to be upside down again. So down the from the upper left to the lower right, we should see this dark cloud. So it's going to be right here. So let's see if it is. All right. And we're going to do a 50-second shot here. I'm actually going to go to 250 gain for this one as well. Alright, so we're going to get out of the low light mode and head into deep space mode. Alright. Very nice. Well, I'm glad I could supply you guys with a little entertainment, you know, instead of the Super Bowl, I guess. Toner Low says, beautiful clouds in space. Yeah. Yeah. Hein, thank you for the thank yous for the super chats. Very kind of you. Yeah. Yeah, this is, let's see what we got. Did it come down? Do we see the dark guys right here? Yeah, we do. There they are. All right. Now, the question is, wouldn't it have been better if I actually started guiding? Probably. So let me do that, and then do star selection and guide. Okay. So I had to do this. Mr. Django, you just got up, man. It just got up over in Belgium. It is probably early in the morning for you. Okay. Lori says, very cool. Thank you. There we go. So now what we'll do is color correct this. All right. And do this, which is going to move things down a little bit. But I want you to see this beautiful area within the Monkey Head Nebula. It's really pretty. All right. And we can ride this up the curve. And I'm only looking at the white curve, which is the average of the red, green, and blue curves. And that is very telling because it tells us where the data begins. If we come down to where the curve stops, well, then look, it's all washed out, right? So if we ride up this curve, as long as we don't pass the top, we won't lose data. See, we're losing data now. But if I go right to the very top and then go to the left a little bit, that gives us the maximum amount of our view. That gives us the maximum data. All right. This is a beautiful segment of this nebula. It's full of oxygen and it's full of hydrogen. Where's the oxygen? You tell me. You can tell me where the oxygen is in this nebula right now from what we've talked about earlier. So just put it in the chat. And when you put it in the chat, make sure you tell me why you know it's oxygen. Say the oxygen is, and give me a location in the image. And the reason is because, kind of like a little test, right? I'll give you a little hint. The red is hydrogen. It's not the oxygen. I guess that doesn't leave much, does it? Alright, so we have 3 images that we've stacked so far, and already you can see some brilliant detail coming in. This is gorgeous. It'll probably know this one. Yeah, it does. And I'm going to do this. Set the target name. And then I'm going to say Monkey Head Nebula after it. You can't see the Monkey Head Nebula. I'm sorry, you can't see the monkey head shape. Because we have too tight of a field. So it's kind of hard. Fantasy is absolutely correct. The oxygen is it's actually bluish green. It's teal. It's a teal color. Yes, Robert Waters is 100% correct. It's that teal blue. It's over here. There's oxygen over here. And it's actually, it's been ionized twice. It's doubly ionized oxygen, meaning 2 electrons are bounced off the atom, and when they rejoin the atom, they travel to 2 different discrete locations, and when they do that, they have a color of teal blue that is the predominant color. Yep. So we're not seeing the whole monkey head in this image, unfortunately. I'm glad we did this one. I've never done this before with this telescope. And it's high in the sky, so it's beautiful. Look at that. Wow. That's really pretty. You can almost see 3-dimensionality to that, can't you? Kind of interesting. That is neat. Lori says, in my defense, I did remember you said oxygen was the 3rd most prevalent element in the universe. Very good. Exactly so. You would have got extra credit for that one. And Galargo was going to say, dang, I was going to say the blue because of abundance. Well, abundance, yes, but really it's the color, because it shows that we have a different type of gas that's been ionized out there. Red is hydrogen. That one's pretty clear. Oxygen, we have to be careful too, because sometimes there's a lot of dust in a nebula, and that blue color, like around the Merope Nebula, is not the same as this blue color. All right, so that's why we have to be careful, because that blue color, like in the Merope Nebula, that's a reflection that the dust is taking the blue light from the stars and scattering it out to the universe. So it's reflecting that blue light back to the universe. So it's literally the color of the star. Okay, this here is not the color of the star. It's actually a teal blue. Let me see if I can get a slightly more. Yeah, so you see it a little better there. Okay. So we can pull it out a little bit better. Okay, there it is. All right, and you can see now this is more of a teal blue. So there's oxygen in here. And depending on the sensor of your camera, this particular nebula might show that oxygen as a green color. And it's only because of your color response of your sensor. It's really a teal blue. I could make that look green if I wanted to, just by changing the color response of the camera, which I can get to in these parameters down here. This, for those of you who have not been here before, this is our stacking window. This is where we take photo after photo after photo and make an image sandwich out of them. Okay, when we actually, when we get rid of this guy and we show you the full size, now these are the observatory views here for the telescope 2,600 miles away from me here. This is telescope visualization and control should I need it. And so is this over here, but this is also camera and camera management over here. So I also have filter management over here. I currently have, 5 different filters. I have a radian filter, which is one type of narrow band type of a filter. I have this UHCS filter, which shows nebulae very well. Has a little broader view, a little broader width to show a little more of the light on either side of the main frequency we're looking for. The SA100, that's a different kind of filter. That's a grating, so we can actually see the spectral colors of a star. And under the right conditions with stars, we can actually see the elements in the star's atmosphere. But it's not it's not as good as having a true spectrograph. And if you look down there in the lower right corner over here, you see Asterion. Asterion is a foundation that has Lowell Observatory in it, and they gave us a donation or a grant for getting a spectrograph for this telescope, and so we're going to get that. And we're probably going to mount a second telescope on top of this one and make that one have a singular duty that it's going to do, and that is to be a spectrograph. And so they gave us the money for the spectrograph, which is very, very nice. So we're in the process of doing that too. So that said, so now you kind of know your way around this screen, right? And of course we have our planetarium that's connected to this entire system as well. So you can see the monkey head is pretty big compared to what we're looking at. But with our Sonoran telescope, once we're getting that up and running again after it, the Marianne and Tara visit it Tuesday, we'll be able to show this entire nebula, and the view is like this. It's much bigger than this. It's a wide field system. This is a narrow field system. Narrow field systems show you much more detail in these small areas. The wide field can't show us all that detail, but it has its function to show you the vast nebulae out there. It's also a very, very fast telescope, meaning we've converted it to go from its natural f8 f ratio, it's called, to f1.8. So it means that the telescope runs 25 times faster photographically. So that means that if we take a picture, like right now we're doing we're doing what, 45 seconds, 50 seconds. We're doing 50-second photos here. Well, the telescope runs 25 times faster out in the Sonoran. So if you divide that by 25, right, you can find we literally will not even have to take a picture of more than just a few seconds to get the same result, but overall. All right, so this is kind of neat. It's a beautiful setup. So we have the wide field and we have the narrow field. Awesome. So that said, you can start to see more details showing up here. More details in the subtleties in this oxygen, doubly ionized oxygen nebula segment here. Just beautiful. This is the part I wanted you to see before we close for the night. And I'll show you the closing for the night too when we do it. So let's see how many stacked here. We have 14 stacked. We're going to go to 15 on this. You can see that number here. It says 14 stacked. It's going to be 15 stacked in just a minute. All right. So what it means is we've been taking basically 50 seconds and we're doing 15 frames. So effectively, we're taking pictures for about 15 minutes here, right? So this is 12 minutes 30 seconds. Okay, so we'll save this here. All right, save it exactly as seen. So the physical ping file in 30 seconds will be up at skytourlive.org. You can go grab it and examine it, check it out, do whatever you like with it, and I hope you enjoy it. So that all said, I am going to, it's midnight here. I'm going to go away for the night. I did this one more. This was the encore. Hope you guys enjoyed it. And I will see you in the next stream. This was really nice tonight. Thank you guys for joining on such a important night with the Super Bowl. You know, no matter who you root for, it's just football. This is the universe. Football started out there. That's where it all started, out there. Anyway, you guys have a good night, and I will talk to you soon. But before you do that, oh, thanks, Poogerson. Very kind, man. Thank you so much. I'm so glad you're helping us out. Thank you so much. And so nice to see you. And do subscribe if you haven't yet. Again, it's all free. You know, we appreciate anything you do for us. All right, guys, I'm going to save this one more time. Let me first redock this so that we can do that properly. Here we are. So we're at 16. I'll wait for the 17th. All right, and then we'll save it. There we go. We'll save. Every one we save, we have less noise. A rule of thumb is if you take 2 exposures, you have half the noise from 1 exposure. So 10 exposures is half the noise from 5, you know, digital noise. So the more exposures you have, the less noise you'll have. So we took 17, right? So that is basically like having basically a less noise than 8 exposures, roughly 8.5. So there we go. So we're done with this, and I might as well wait till 18, right? Because me and my big mouth, I keep talking. Next thing you know, it'll be 4 in the morning. Well, we're almost done. So we'll go to 18, make it an even number. Okay, we got 0 seconds, and boom, there we are. So we'll save 18. Okay, and we'll save it exactly as seen. Now, let's get out of here, and we will go back to our low light mode, and I will show you the good night procedure. So here's what we're going to do. It's going to be this guy that I will bring in bigger. This is the view looking in our building. That's our Starlink antenna you see on the left there, upper left. Let me bring this over here. Let's do this. All right, this is the one we want right here. I've got the view. I had to bring it up. So let's see if anyone's viewing over on the other side, as I said. Nope. And not using his telescope. It's not pointing up in the sky. However, up there, you see, well, you don't see, do you? It's not obvious. Oh, I see. I stopped moving after this. Does that mean this is done too? Okay, looks like I lost my connection briefly, but we're back. Okay. Alright, so there, in the sky, after this stabilizes, oh yeah, it says I lost my connection. I'll be back. Don't worry. I'll come right back. Alright, so let's bring it back. It should just be right there. Yeah, I know, huh? Okay. Alright. So, I'm in your way, obviously, so I'm going to move this out of the way. But you'll see right there, we have Orion. There's Betelgeuse right there. Alright, and there is the belt of 3 stars. There's the Orion Nebula down here. Kind of hard to see. But I am going to get rid of some things here. All right, get rid of this guy. We don't need it anymore. This is the program I wrote to control all this stuff. And we don't need this. Okay, and let's bring our view back now. And let's go back down into our building. Okay. All right, so now we're going to close up for the night. So what I'm going to do is I'm going to get rid of these views because I no longer need them. I'll bring up the main view, and I'm going to tell it to go park the telescope for the night. So you'll watch it move now, and it's going to go flip around and park itself on the other side. Now we're moving, you know, several hundred pounds of telescope, so obviously it has to move slow and methodically. And as I told you before, this is the business end of it down here. Okay, we have a filter wheel here. Okay, we have an we have the off-axis guider, we have the camera, and we have a focal reducer that actually allows us to see a wider field of view. And this goes down to its little spot where it will stop. Okay, right about there, and it should stop here. And we are now parked. Okay, so I can disconnect the telescope here. Okay, and shut that down. Yeah, we can do that. And then we turn off power. Power's off, and I shut the building. And here we go. There it goes. And we're saying goodnight for the evening. There we are. And so up in the sky, still a beautiful night up there. And just wanted to let you all know that I really enjoyed doing this with all of you, and hopefully you kind of enjoyed seeing a little behind the scenes there of closing up, because that was kind of cool. In any case, I hope you guys had a good time, and we will talk soon, and I hope to see you again. All right, so you have a good night, and we will talk the very next time we do this. Good night, everybody.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming light for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels bright. your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new.